On this problem set, what we're going to do is just work on a little math. We're going to look at the relationship between the p function, pH, pOH, etc. So let's start with the p function. The p is the negative log. So it doesn't matter what you have. You can take a pH, pOH, pH, pKa, etc. Now, to walk through it, so if we start with a hydronium ion concentration and we want to take the p function of it, so what we'll do is the negative log of the H plus is equal to the pH value. So if we want to reverse it, then I'm going to go ahead and draw a line here. We're going to reverse it. If we start with the pH and we want to go back to the hydronium ion concentration, and remember, if you're doing this, if you start with the pOH, you go back to the hydroxide ion concentration. You can go either way, and I'm going to walk you through those. Then what we have is that the pH is equal to the negative log of the hydronium ion concentration. So if we're doing math, we would move the negative to the opposite side. The inverse function of log is the 10 to base 10. So if we take 10 to the negative pH is equal to 10 to the log of the H plus, then the net effect is these two cancel out, so we are left with 10 to the negative pH is equal to the hydronium ion concentration. Now, as I said, this will work for any p function we have. More about that one in just a second. Let's go back up here and look at the relationship between pH and pOH. It's equal to pKw, which, remember, kW is 10 to the minus 14th. So pKw, is 14. So what that tells us is we have an entire variety pack that we can work with. So let's list our pH. If our pH is 2.12, then I'm going to find the hydronium ion concentration in just a second, but let's go ahead and list our pOH, and if we're doing that, we'll do the hydroxide ion concentration. The relationship is such that it doesn't matter which of the four values you're given, you can walk them back and forth. That having been said, we'll start with the pH of 2.12. Now, to find the H plus concentration is going to be equal to 10 to the negative 2.12, which comes out equal to 7.5858 times 10 to the minus 3. Should have made my columns bigger. So that species. If we're going to go across, then we can look at it and say, okay, wait a minute. If the pH is 2.12, then the pOH is 11.88. That means my hydroxide ion concentration is going to be 10 to the negative pOH. That being the case, if we run the math, we're going to get 1.3183 times 10 to the minus 12th. Now remember, because our relationship of H plus to OH minus is equal to KW, then your exponents typically, when they're multiplied together, which means you add exponents, should be about negative 14. Okay, so negative 3, negative 12 is negative 15. That's close, 1 or 2 off. Okay, so we're going to do this again, except this time we're going to use a pH of 5.75. If our pH is 5.75, then our pOH is 8.25. That being the case, if we take 10 to the negative 5.75, or the negative pH, we're going to get 1.7783 times 10 to the minus 6 is my H plus concentration. To do my OH minus concentration, it's 10 raised to the negative 8.25, which comes out equal to 5.6234 times 10 to the minus 9th. Now, notice where the pH is really low, our hydronium ion concentration is much larger than our hydroxide. As our pH is rising, our hydronium ion concentration is dropping, and our hydroxide concentration is rising. We're going to do one more in the basic. Remember, this is acidic, this is still acidic. 7 would be neutral. Let's do 9.34 as my pH. If that's the case, my pOH is 4.66. To find the hydronium ion concentration is 10 to the negative 0.34, and that's 4.5709 times 10 to the minus 10, excuse me. 10 to the minus 4.66 is equal to 2.18776 times 10 to the minus 5th. So notice, as we became more basic, our hydronium ion concentration dropped and our hydroxide concentration increased. So as long as we've got a pH, a pOH, or a hydronium ion concentration or a hydroxide ion concentration, we can go back and forth. Because if we were to take any of these concentrations and take the negative log of them, we'd get back to the P function. So this is an explanation of converting back and forth between the P functions.